Thanks, Ben. And thanks, everyone, for joining me here today. It's a real honor to present to you guys. Thank you, JSConf, for making this happen. As Ben said, I'm going to talk about visualizing our applications, the code just being a part of it. But as we'll see, and as we all know, our apps are so much more than code. So we'll see whether we can use some 3D visualization techniques to get a better perspective of our apps. So we'll use this as a case study, the awesome to-do app from the 2D MVC project. I'm sure all of us have maybe created some version of this app. Some of us may have even contributed to the project using different frameworks to create a to-do app. So I think it'll be a good example that most of us can relate to. Just for those who may not be familiar, so that they understand what they're looking at when we get into the code, it's a to-do app. You put in your to-do items, you check them off, you can sort them. So you get different views, and that's essentially the functionality, okay? So we ask, what's an app? And the first thing that comes to mind, it's code. Looks something like this. We're all very intimately familiar with this sort of view. In order to sort of maybe better understand the reasoning why we need to see things beyond just the code, and not just see them, but share them, show them, we'll look at a more tangible example like coffee. So say, hey, what's coffee? It's ingredients, something like this. In fact, very simple ingredients. You might say, water, coffee beans, that's all. Now go and tell that to those guys outside serving us the espresso coffee from the beautiful folks from the barn. But by the way, are they not great, the barn coffee out there? Are they great? Awesome. Good job, JSConf, for setting that up. And you see their setup. First of all, there's people. So coffee is not just ingredients. We've got a person taking our order. We've got a person making the coffee. We've got thousands, maybe tens of thousands of dollars of equipment. That espresso machine that they're using to serve the espresso, $5,000. I know. I used to have a coffee shop. So already we see that the coffee that we take for granted, we can get a much better perspective when we think about it in this sort of 3D way. We have a sense of geography here. If our coffee shop is in Baltimore, and we're here in Berlin, that's no good for us. So all these things come into play when we want to think more broadly about where our coffee comes from, what our coffee really is. So the key message here is sort of a no-brainer. Coffee shop is a much bigger deal than coffee itself. The same thing I want to show you when we talk about apps in general. We're using the to-do list app as our sort of case study, but a to-do list app is a much bigger deal than a to-do list or any given feature. So the app is a much more bigger deal than the feature set that is designed. So when we put the 3D view up of the coffee shop, we're able to get perspective on the scale of the coffee shop, the location of it. We're able to see our people, our processes, our things. And then we have traceability to concrete artifacts, the actual coffee machine, the location of the bathrooms with respect to the entrance. That sort of, those concrete things gives us a good appreciation for what's involved. And everybody understands that 3D diagram. Whether you're a coffee farmer, a coffee maker, a business owner, a customer, we all intuitively understand that. So that's what we're hoping for in our 3D application view. So we have on the left-hand side, the coffee shop. The inputs into that sort of visualization are things like the ingredients, the inventory, the people, and the infrastructure. And we have that output. The analogous inputs for the to-do list app would be our code, our support scripts, our people, very important, and our infrastructure. And somehow we're going to come up with this 3D diagram. So that's hopefully what we'll get to together today. I'll use some of your audience participation. I can see that that's needed as we're going this far into the conference. Things are getting a little, folks are a bit more tired. So we start with the code. So we started out with the app as code text, and now we're already getting to something beyond the text. We're now talking about the files, the folders, the file system. So already, there's a little bit more to our code than just the text file. And here we just have a subtle maybe benefit of the 3D view, just the beginnings of maybe the value of 3D visualization in terms of getting a better perspective. Here, for example, we can see the entire folder structure, the sort of thing that you would have to click through every single folder to see how deep they are. Here in one view, if we do this sort of leverage our third dimension, we can see, the top-level folder consists of an assets folder and a JavaScript, JS folder, blah, 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 and so on, across the whole code base. So maybe some value there. Now, another way that perhaps we can gain some value looking at things in 3D is if we juxtapose the files, the text files, next to the 3D diagrams. Again, we have a sort of visual way, quickly, shorthand to see what files are important. Visually, you can see the file in front. This app.js file has less code than the one behind it. So it gives you a little bit of sort of overview perspective, a shorthand perspective, if you will. But we obviously need a lot more. Just to look at our file system in 3D, maybe not directly a huge amount of value with that. To explore further, let's compare with a more complex app. So we introduced Discourse, another great open source app that folks who made it available. I think some of the folks behind Stack Overflow. It's a forum software, so people interact, write blog messages, post comments. There's some mail and bulletin board functionality, so it's a very complex app. So while I have two open source apps here, and someone mentioned open source just before I got up, why don't we just give a quick round of applause for people who contribute to open source, okay? Awesome. So what can we see in 3D? We can see a relative size of things. And now, one thing we see is that, Discourse is much bigger than the to-do MVC. We put it next to a model there. Let's say someone in the room I sat next to, Hae-suk from Korea, studying in Finland. I just met today. She's the manager of our team. So standing next to the code base that has been modeled per certain dimensions, 2 inches, half an inch per each file with the 2-inch separation, she gets to stand and say, look at how big my code base is. At the same time, she can also share that with her management by saying, hey, look how big my code base is. Again, we saw a talk on Friday. Kai from Microsoft talked about lines of code that changed in the new Microsoft browsers versus IE. And he talked about 220K lines of code, 140K lines of code. Great stats, very important. We all use stats like that for different reasons. Here's another way to show that same relative size of things while looking at the actual file system, and also perhaps providing some perspective to folks at a glance view. Hey, there's a big app, and it's as complex. That's a life-size, well, not life-size, but that model is to scale. That Airbus A380 is to scale of that Discourse app, and that's just the JavaScript portion of the Discourse app. Discourse app is a Rails app on the back end, so that's not even including that. So again, I think there's some value in showing things that way, both for us as developers, technologies, but also for our business partners. I think that should help our partners in understanding what we do. So what else can we see? Can we gain any insight about the structure of our code beyond, okay, it's a big code base? So first, to do that, let's just look at the folders of the code. Let's ignore the files for a second, and that allows us to have a more compact view. So that's what we see here at this first shot at things. Now let's sort things, but let's sort them with the advantage of a 3D perspective. So let's use X, Y, Z planes, or everything we have at our disposal. So if we do that, we can sort, in one direction on the X plane for one folder level, another sort in another direction on the Y plane for the next folder level. And so we're going, using advantage of all our planes a little better, which gives us a more compact code base. So now that code base that was the length of the A380 that had no hope whatsoever of fitting on the screen, now we can see in one compact view. So what's the advantage of that? First of all, I think that by itself is awesome. I mean, I don't know how many of you have gone through a code base, clicking through directory structure, being able to see the whole directory structure in one view itself is awesome. Now I say, you can go directly to any file at any level. Another sort of quick benefit of looking at things in 3D. We can see patterns. It doesn't really take an expert eye to see, hey, this one on the left, it's named admin. This top-level folder is named admin. This top-level folder on the right is named Discourse. They're fatter, they're longer. It looks like the folders in there have names like models, controllers, components. maybe they're kind of the two main apps within this our app. So again, these are some of the patterns that I think we want to see when we're exploring a code base. Now we can see in 3D, I think, rather quickly. And also, non-technical people might also be able to get a maybe appreciation of that without understanding the code base so much. Of course, now we do need to see the files. So when we do want to explore any folder, we can click any of them or all of them at one time. Again, some of the limitations of the current methods of viewing our folder structure, either using the command line or using the operating system GUI, has limitations, of seeing one folder, one directory at a time, or it's clunky even when you want to see more. So that's all 3D code. But Ola, you said app is not just code. You just spent the last 10 minutes talking about code. Okay, so we need a computer. We start off with the code, but now we introduce our runtime. We have to put a computer into the picture. And in this case, we can see in one view that, we have a certain code base. It runs on a Windows operating system. It actually needs a browser as a runtime. And so, again, shorthand view of getting better perspective of what our app looks like in a shorthand. We also need a user. Another thing that's missing in a lot of diagrams, either it's oversimplified, stick figure user, or non-existent at all. So let's introduce our user. Let's have them in the view. Some apps or software don't need a user. Perhaps they interact only with the environment or sensors or other apps. But here we're talking about a web app, and then there's a user involved. So let's show them. Now we're talking in this particular room about a special type of app or software called web apps. So we need a web server. And so here's one way we can visualize that. We introduced a new machine. That's the white platform there, and we have a server. It's the Node Express. It has an NPM dependency, and it serves the HTTP. In this case, on the same computer. That looks like our developer's machine. Clearly, it's still not what an app looks like really in the wild, but we're getting there slowly. So now we've introduced developer and developer machine and developer tools that go with that. And now we can also show and share, perhaps succinctly, but certainly in a cool way, that developer does more than code. Clearly, there's the build, there's test, and there are tools that go with that. Again, some more dependencies, some more installations shown in orange. As you are all very familiar with, Git was just mentioned in the talk before mine. Others have talked about the transpiling tool. Peter Mueller did a great talk on Friday. I recommend anyone who did not see that to check out the video, talking about a different language transpiling tools that we have to deal with, and perhaps some better ways to do that. Here we can visualize that among the other tools that we use. So here's our view about our developer. Some perspective about the kinds of things that you see at a glance when you look at a system or an application, in particular a development environment this way. We can do a technology comparison. Here we say, another stack we could use for our web app is Ember, and Ember has a facility called an Ember CLI that includes some of those same installation, those separate installs that we had to do for transpiling or testing, build dependency management. It's all in Ember, so we can just do a visual comparison. It doesn't tell you which one is better or worse, but it just gives you some perspective. If you saw one developer's machine in this view versus another developer's machine in that view, you can see the difference rather quickly in the stacks they use and how those stacks are different. Same thing with Rails. Rails is a totally different technology from our JavaScript frameworks, the server-side framework, but we can still visualize the developer environment. So here, just trying to show the versatility of looking at things in 3D and how it's not just, for this specific type of app. I think almost any code base and almost any type of app can benefit from this kind of visualization. So now we've talked all about developer tools. What happened to our user? Our user's way over there, or over there. And no code for the user, poor user. So what do we have to do? We have to do some deployment steps, which is more tools and more roles for our development team, in this case, our single developer. By the way, we should name our developer. I'll name her Sandra, after someone I met today here from Zimbabwe, who came all the way from Zimbabwe here, thanks to JSConf diversity program. A very, very great effort by JSConf bringing people in. So there's Sandra, and now she has to deploy our code. More tools, we might have use an FTP file program to transport the tools. We might use Amazon S3 for our storage. It's the simplest way you can deploy a single-page app, a static app. So we do that. We deploy Amazon S3. We have to configure some DNS so that the domain names work out right. Todd spoke a little bit about some of the issues that may come up with DNS routing and so forth. And guess what? There's more code. Whatever it is that we configure in S3 and in Amazon, default routes, the default routes, error routes, error messages, error screens, those are code. They make up our system. I mean, this is part of the things that just totally get lost whenever we either point to our code and say, hey, the code is the app, or when we try to do a little bit better than that and we draw the diagram of the app. Oh, here's our S3 cloud. Here's our clients. Here's our server, in sort of the two-dimensional ways that we do it. And I think that shorthand is great. It's awesome for us as engineers, but I think the value of getting a little bit more sophisticated is very beneficial I think for us as engineers, but certainly for our partners, clients, bosses. So we deploy everything. We could say, and then we should ask, are we done? Things are working. App has been developed, has been put in the cloud. Our user can download it, can make their to-do list. But as it generally goes, we need more features and we need more developers. So Sandra needs a partner, coworker. So we introduce another developer with another development environment, and we model their development environment. Theirs might not be Mac, but for the sake of this talk, we've just said it's the same sort of setup. So we bring in Brian, who spoke a little earlier, from San Francisco, all the way here from San Francisco. And of course, what kind of development team are we if we don't have someone from Silicon Valley on the team? So Brian's here to collaborate on the app. So now they have GitHub as a shared repository. Now they're using GitHub as a shared repository. They're both doing their separate build and deploy and test step. How long is it before a different operating system, a different configuration on one person's machine makes it pass here or fail there? So we need to have a shared dev and build and test environment. That's what we've done and created up here. In this case, we've used Amazon EC2 as our cloud infrastructure. We have a Linux operating system. We're able to see visually, oh, that's different from our Mac. Again, some of those sort of things that make up our system, very important things that make up our system that I think often get lost way too easily when we talk about our systems. So we got more tools, more code, more configuration. Again, we ask, are we done? But some of you are already looking at that gap, that gulf between the dev and the prod, and you're saying, something is missing. You might also be looking and saying, hey, this dev part looks a whole lot different from prod. My development environment is not made up of S3. I can't have Amazon S3 on my machine here, right? So that's why we have what we have. Similarly, S3 does not support the build tools that we've gone and set up using our EC2 instance. So these things are so different. Maybe we need something else. Introduce staging environments. Try to make that identical to production. We have someone playing that role of testing our pre-production app and staging. Let's call that person Todd. Because as we could see in Todd's presentation, Todd is anal about application performance, quality, and errors. So if anyone can catch any errors before going to production, it's Todd. Thankfully, he also has some tools for us to even catch the errors in production, but I think it will be a good candidate for us to QA our code, our app, before we get to production. So are we done? Cloud storage, we didn't talk about that, right? At this point, we're all using local storage for our app. And so we need database, some code for the database. We need some database, actual executable database app, database installation. So we've shown that there in red. Now we've got to upgrade our staging. We go from S3 to EC2. Again, I think the value of the 3D visualization is that just visually, you look at the S3 versus the EC2, you can see that, it's different, and you can see it's significantly different. And crucially, our teammates can see that, we as a team, and our partners, clients, customers, executives. So when we said, it's going to take some more resources, it's going to take some more time for us to go from S3 to EC2, they have a way to visualize this. They don't just have to, think that, oh, whatever magic you guys do, just do it faster. I mean, you drew S3 as a circle, and so make it so, right? But now we can give them a better perspective for what's involved. So with that, again, you can ask the question, are we done? Valid question, but I think you're seeing the pattern now, right? The pattern is, really, we're never done, right? I mean, that's sort of the reality of our lives. There are all these things that I've not touched on that are part of our daily lives, different infrastructure, operational things that we need to introduce. We talk about containerizations now instead of virtual machine infrastructure. We might use in-memory data stores like Memcache and Redis. A whole bunch of stuff we could do on the infrastructure side. Same thing, we have services that we generally need to plug in here, message queues, workflow engine, other kinds of storage. We may introduce different communication pathways using WebSockets or peer-to-peer or streaming. There were some great talks about that earlier. I recommend Thomas's yesterday evening talking about streaming and peer-to-peer, which you should check out if you missed it yesterday or on Friday. So I think the 3D view helps us visualize better all these aspects of our system. And so hopefully at this point, we have some analogous way of looking at our app as a system, including people, including processes, including assets and resources, similarly to how we might think of the physical thing, a physical thing like a coffee shop, a physical system like a coffee shop, I beg your pardon. Again, we see the same sort of insights. We can have a perspective of the location and scale of our application. We can see the people, the processes, the things, as well as have traceability to concrete artifacts. And I think this is intuitively understood. So talk a little bit about the tools. I'm sure many of you are wondering, so how do you do it? What's he showing me? So in this case, what you're seeing here today uses Ruby as a scripting language, integrating with GitHub. I'll talk about the integrations that I've done so far, and a 3D modeling tool called SketchUp Make. Along the way, I did similar, I produced similar results using JavaScript and the 3JS library, as well as JavaScript and another modeling software called Tinkercad. I can talk to you offline all about why I'm not using those right now. I'm still evaluating. There might be some things that I will end up doing more with. And then we talk about API integrations. Currently, GitHub is the only one. The source code that you saw there from Discuss or To Do, this is based on the code base of those apps from GitHub through using the Ruby scripts, using Ruby and the SketchUp modeling tool. I created a visualization of the app code base. I think very interesting future work for me and others who are interested in this kind of field will be to integrate whatever modeling tools they come up with, and I want to do it with this. Other source control systems you see there, other cloud platforms. It would be great to directly integrate with the cloud platform, query Amazon and Azure and Heroku for the status of our applications, the size of them, the configuration of them, and show those in our visualization. And similarly, it would be great to integrate with the various CI, continuous integration, and continuous delivery tools that are out there that some of you are familiar with, CodeShip, CircleCI, and so forth. Still along the lines of future explorations, I'm working on getting this stuff open sourced. It's not right now. I can't give you a URL, say, oh, go there and get the modeling tool. I'll be adding more canned components. Right now, you saw everything sort of JavaScript biased with AWS infrastructure. Obviously, the same things apply for any other infrastructure you use or any software development tool set you use, Java or .NET or what have you, Ruby. And what would be really awesome would be to integrate with the various 3D interaction technologies. You have Google Cardboard, Microsoft HoloLens, Oculus, Leap Motion, and so forth. We're not there yet. I'm not there yet. Would be great. Could use your help for that. Some of my motivation for that, you guys all know the quote. Really hard to find who it's attributed to. That which is measured is improved. To that, I add that which is visualized is improved. Even if we're not empirically and quantitatively measuring something, just being able to visualize it, being able to see symmetries, see patterns, see scope, see some degree of complexity. Of course, it's not the final word on how complex a system is because you see something like this, but all that kind of visualization, the fact that everybody can see it, not just us developers, but our partners, our businesses, I think can help improve any application or, in fact, maybe any software system. So I could really use your feedback, as I said, either on some of the current stuff that you see or some of the future integrations or future explorations that either you can help with or you're doing yourself. I'd love to hear about it. That's my information. And with that, finally, I'd like to say thank you to you all. Thank you to JSConf. Thank you to Berlin. All the Berliners and Germans I've met have been super awesome. You guys have been great. Thank you, everyone.